Kimberto presents, as part of a project for College of Marin Geology 249, the coastal landforms of Santa Cruz, California. This photo was taken from the Old Cove Landing Trail a few miles north of the city of Santa Cruz. Indicated are several landforms typical of this portion of the central California coast. To the left, jetting out into the ocean, is a headland. We also see steep, jagged cliffs, evidence of the erosional nature of this part of the coast. The level, stair-step features looking off in the distance are known as marine terraces. And next to the narrow beach, the cliff exhibits another erosional feature known as a wave-cut notch. We will examine all of these and other coastal features of the Santa Cruz coastline. The Pacific coast of the western United States is an active continental margin. Active continental margins are characterized by mountain building activity, which includes earthquakes, volcanic activity, and tectonic motion resulting from the movement of tectonic plates. This diagram shows an oceanic tectonic plate on the far left, which in our case is the Pacific plate, subducting under the continental plate on the far right, which for us is the North American plate in California. Uplift of the land at and near the subduction zone is a result of this tectonic activity. In addition to being an active continental margin, the Central California coast is also an erosional coastline. That is, a coast dominated by erosional forces, as opposed to a depositional coastline, which is what much of the Atlantic coast in the United States is. This illustration shows many features typical of an erosional coastline, such as wave-cut platforms, headlands, arches, and others. We will examine these features more closely, highlighting examples from the Santa Cruz area. This photo from the beach in Capitola, just south of Santa Cruz, exhibits some of the hallmarks of an erosional coastline. The steep cliffs are formed by the ocean undercutting the sea cliff, which then results in the cliff breaking apart and falling onto the beach. Fossils from the Purísima Formation can be seen here in the cliff debris on the beach. A narrow rocky beach with wave-cut platforms are clearly seen at this location. Here we see the progression from a crack in the sea cliff on the far left to a stump on the far right as a result of hydraulic action, abrasion, and erosion. The crack grows, eventually becoming a cave, and later becomes an arch. The arch invariably collapses into a stack, which erodes into a stump. If you see taller stacks on the shoreline, they may have been arches not so long ago. There are sea caves carved into the cliff at Wilder Ranch State Park. You can almost envision these becoming arches at some point in the future. Wilder Ranch State Park is about 3 miles north of the city of Santa Cruz, located on 7,000 coastal acres with more than 35 miles of trails. I took this photo at Natural Bridges State Beach in Santa Cruz, a few miles south of the Wilder Ranch State Park. The insert photo is from the same location almost 100 years ago. I did not take that photo. The photos show how much the coastline has changed over the last 100 years. Eventually, this existing arch will also collapse and erode into stumps. A wave-cut platform is a horizontal or low-angle rock ledge found at the base of a sea cliff or along the seashore. These are formed by wave abrasion and erosion from the sea cliff. This diagram illustrates the formation of a wave-cut platform. Waves attack the base of the cliff, which undermines the cliff, causing it to collapse and retreat. Abrasion and erosion flattens the platform. Rising land may over time elevate these platforms above sea levels, resulting in marine terraces. This is a wave-cut platform at the Swift Street outcrop in Santa Cruz. Towards the water, you can see tide pools, which often form at low tide on wave-cut platforms. You can also see outcrops of the Purísima Formation and the Santa Cruz Mudstone in the cliffs here. We will revisit this interesting location in a future presentation. This fantastic view is from the Coast Dairy State Beach, about 8 miles north of Santa Cruz, just off Highway 1. We can see stacks, stumps, a wave-cut platform, and a bay with headlands on either side of it. The expanse of almost level land overlooking all of this is a marine terrace. Marine terraces are raised platforms of marine origin formed by erosional processes, the rising and falling of sea levels, and tectonic uplift. Marine terrace formation begins with high-energy waves cutting into a sea cliff and forming a wave-cut notch as shown at number 1 in this diagram. Number 2 illustrates tectonic uplift, raising the land above sea level. Number 3 and number 4 exhibit marine terraces above sea level formed in a stair-step fashion. If you are interested in marine terraces, be sure to watch my video, Marine Terraces of Santa Cruz, California. Here we are again at Wilder Ranch State Park, where we can see this marine terrace, which is the closest terrace to the beach, stretching inland and southward. Note the wave-cut platform on the right. This illustration shows how differential erosion can result in the formation of a bay. Differential erosion occurs when bands of soft rock erode more quickly than harder rocks, forming bays with hard rock headlands on either side. We can see how the center band of softer rock eroded first, developing a coastal bay. This is Panther Beach, just north of Santa Cruz at low tide. This small bay formed out of the coastline with headlands on either side of it. Note the stumps in the shallow water and the wave-cut platforms on the right. Here is a map of the Santa Cruz area with yellow stars indicating locations I visited for this presentation. It's only about 20 miles from one end of this map to the other, but I would allow at least 2 full days in the area to visit and explore these locations. This is near the Swift Street outcrop in Santa Cruz. Note the wave-cut notch to the right. However, I took this photo because it is a good example of the use of riprap. Riprap is a layer of large stones or other material placed on shorelines to protect structures from scour and erosion. Note the proximity of homes to this rapidly eroding shoreline. It's no wonder that people come from all over the world to marvel at the California coastline. Kimberto thanks you for watching Coastal Landforms of Santa Cruz, California. If you enjoyed watching this video, please check out my other videos on the Santa Cruz coastline or other geology-related subjects.